In this lecture, we're going to learn about Rvalue references. And this is a mechanism we have in C++ to extend the lifetime of temporary values. So when a Rvalue reference is bound to a Rvalue, the life of the Rvalue is extended, and we can manipulate that variable throughout the life of our program using the Rvalue reference. Let's see how this works. Here is a simple example. We have our add function that we have seen in the last lecture. It is just going to add up two values we get in these parameters, and we are going to return by value. So this is going to return a copy to whoever happens to call this function here. We can set up our two variables, x and y, and set up our expression here to add them up. This is still going to give us a temporary value, and this is going to live in a temporary memory location. So for example, we are going to have a 15 in here, and this is going to be a temporary memory location. But what we do is tell the compiler, I don't want you to destroy this memory location because I want to use it as is, so don't destroy it. And we tell that to the compiler using the syntax we have here. We say int and say ampersand, ampersand. This is going to tell the compiler that this is a Rvalue reference, and the compiler is not going to destroy this memory location. We will keep this reference, and we can use it to mention or use this value here later in our C++ program. So for example, way down through the execution of our program, we can reuse the outcome value, we can use the result here, and this is going to work really well. We can do the same using the add function and grab and manipulate our temporary value through a Rvalue reference because we have two ampersand symbols here. This is the way we tell the compiler this is a Rvalue reference, and it is going to be referencing a temporary memory location. And whenever I want to use the value inside, I think we're going to have a 30.3 in here. Whenever I want to use this value, I can go through this Rvalue reference and I can use it like we are using here, and this is going to work. So in other words, an Rvalue reference is a way to tell the compiler to not destroy the temporary values you get in your expressions, because you might need to use that temporary value later throughout the execution of your C++ program. Now, some of you must be thinking, what if I use a regular reference like we have seen before? What if I use a single ampersand symbol and try to store the reference to a temporary value? Well, this is not going to work, as we are about to see in Visual Studio Code. So let's go there and actually explore these things in a little more detail. Here we are in our working folder. The current project is Rvalue references. We are going to grab our template files and put them in place. And we can open this up in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file. We can clean it up pretty fast. And we're going to set up our add function. And we can hop over in the main function and set up x, which is going to be a 5, y not. Now, we want to say x plus y. This is the expression we want to evaluate, and we don't want this temporary to be destroyed. The way we tell the compiler is to set up a Rvalue reference we will use to manage the temporary memory location from now on. So we're going to, for example, say int and say two ampersand symbols. We're going to say result, and we are going to assign the result of our addition to this Rvalue reference. Now, what is going to happen if the compiler executes this line? It is going to take the result of adding up x and y and store that in a temporary. So we will set up a temporary memory location, setting a 15, because that's the result of adding up these two values. But this temporary memory location is not going to be destroyed after the line here executes. What is going to happen is this result variable is going to be a reference to this temporary memory location. Now, after line 14 here executes, we will have the ability to mention this result variable and use it to read, for example, from this memory location and use the value in this temporary memory location somewhere in our C++ programs. So, for example, we can go down here and do all kinds of crazy things. And when we need it, we can try to print out the value in our result variable, which is going to be an Rvalue reference. So we're going to grab the value in result and try to print that out. you're going to see that this is going to work. Let's try and build our program. We're going to pass this through our GCC compiler. The build is going to be good. We can bring up a terminal window to try and run this. And if we run Rooster, we're going to see that our result is 15. And we are grabbing this result through our Rvalue reference. So what the Rvalue reference here did is basically extend the lifetime for this temporary value. We tell the compiler not to destroy it as soon as it is copied from, as we saw in the last lecture. And this is really the main use for Rvalue references, putting a lock on a temporary value and preventing the compiler from destroying that, because you need to use that later in your C++ program. And hopefully you can see that this avoided the copy we had to do, for example, if we didn't use a reference. If we set up a simple result variable, what we did in the last lecture was copy the value from this temporary. So we did a copy. And if this happens to be a really large object, we will be unnecessarily copying this thing. But by using Rvalue references, we can avoid this copy because this reference is referencing the temporary memory location, which we did prevent the compiler from destroying. And this is really cool. We can also set up the same thing using our add function because it is going to return a temporary. So for example, we can say int, and it is going to be an Rvalue reference. Let's use ampersand, and we're going to say outcome. And for example, we can say add 10.1 and 20.2. I think that's what we had in the slides. This is going to work. So we will have an Rvalue reference, which is going to be referencing the temporary memory location where the result for this expression here was stored. So we will store our 30.3 in this temporary memory location, but we won't copy from it. What we tell the compiler is not to destroy this temporary memory location. We are going to be referencing that using our Rvalue reference here. So later in our C++ program, we can go down and say stdcout and print the outcome. And if we build and run our program, we're going to pass this through our GCC compiler. The build is going to be good. If we run it, we should see our result printed out, and that's going to be a 30 because we are basically doing a narrowing conversion from double to int. But if we change this guy to double and make it an Rvalue reference to double, we can build and see that we're not going to do a narrowing conversion from double to int, and this is going to give us 30.3 as we see right here. This is what we want. Hopefully you can really see that Rvalue references are nothing special. They are just a way you tell the compiler that you don't want your temporaries destroyed. You want to use your Rvalue reference to reference those temporaries, and from that point on, they are going to be living throughout the scope of your program. For example, these Rvalue references are going to become unusable the moment we run out of the scope of this main function here. This is what I mean, and I really want you to understand this. We are going to stop here in this lecture. In the next one, we're going to see what happens if you try to move temporary values around. Go ahead and finish up here and meet me there.